Hey guys, this is Mr. Bennett, and I'm going to walk you through how to identify and solve a one-step stoichiometry problem. So, we're looking at our study guide here for Unit 11, test is tomorrow, and if you're still struggling with identifying one-step stoichiometry problems, the first thing that you need to work with any stoichiometry problem is a balanced equation like this one here. So, you always want to make sure that it has coefficients and that it's balanced. If it's not, then you need to balance it first. Once you have the coefficients and it's all balanced, you can then start to solve the problem. So a typical problem is going to be a word problem, and you have to read through it and figure out what are they asking for, what's the target, and what are they giving you. So as we read through this first problem, it says, how many moles of hydrogen do you need? So that's a question. They're asking for a target. Moles of hydrogen, that's our target. That's our goal. Then, as we continue to read the problem, it says, do you need to produce 10 moles of ammonia? So our given is down here. That's our given. That's what we're going to start with. One thing I would mention is that if a problem ever includes something about excess, so if they were to say that you had this question, but they ended it with something like you have excess amounts of nitrogen, that just means ignore it. Okay, whatever it says you have excess of, you can ignore. Just means you have lots of it reacting and you don't have to worry about it. So, once we've got the target and the given identified, your problem for a one-step problem is going to start always with the given. So in this case, you write down the given, 10 moles of ammonia. And they actually gave me the formula right here, but we could find it in the actual problem as well. So I'll put 10 moles of ammonia, and then it's a conversion problem, so you're always going to need a dot and a line. At this point, we should be able to identify it as being a one-step problem, but if you haven't been able to identify it as a one-step problem, I got to remind you that one-step problems are always moles to moles. Okay, so as you're reading that problem, you're identifying your target and your given. Make sure that you check to see what are the target units and what are the given units. If it's mole versus mole, it's one step. Okay? So, at this point, to be honest, if you know the patterns, you should be able to set up the problem, no problem, just by looking at how things cancel and how you add in the units you want. So, on the left of my problem, I have 10 moles of ammonia. I need to get rid of what I'm starting with. That's my given, that's not my target. So I want to get rid of it. And the way we get rid of something is we divide it by itself. So since I have moles, I want to divide by moles. And I want to get rid of ammonia as my substance. I want the substance to be hydrogen. So I'm going to put ammonia on the bottom as well. On the top, I'm going to put my target. My target again is up here. So that's going to be moles. And if you forget what the formula of hydrogen is, go to the formula. In this case, go to the equation rather. In this case, the formula is H2 because hydrogen is a diatomic. Okay. Now we've got it set up, and because we have it set up correctly, what we can see is that the moles are going to cancel out. Moles divided by moles are going to cancel out. Ammonias are going to cancel out, and we'll be left with the units that we want in the target of moles of hydrogen. So the last step is to plug in our numbers. We need some numbers so we can convert. Whenever you have mole over mole, you use the coefficients in the problem. So I find hydrogen in the problem. It has a coefficient of 3. And I find ammonia in the problem. It has a coefficient of 2. So I plug a 2 in there. So I have 10 times 3 divided by 2. So 10 times 3 is going to give me 30. Divide that by 2. My answer is 15 moles of hydrogen. Okay? So for any one-step problem, the generic setup is always going to be the given in moles, and whatever substance you have, we'll say it's substance A, dot line, and then you'll have moles of A on the bottom so that they cancel out, and moles of B, the other substance, on top, and then you get your coefficient numbers from the balanced equation. All right? Good luck. Hopefully you come into intervention today so you can get some more help. Or you can come see me in the morning. I'll be around for a few questions. Good luck.